Determine the limit as x approaches positive infinity and as x approaches negative infinity of x times the sine of 1 over x. Starting with the limit as x approaches positive infinity of x times sine of 1 over x, the first thing to do is try plugging a positive infinity in for each of the x's. That will give a positive infinity times 1 over x goes to 0 as x approaches positive infinity, giving the sine of 0. The sine of 0 is 0, and the result is positive infinity times 0. We have the infinity times 0 indeterminate form here. We will need to rework this. Since the 0 resulted from a sine of 0, we can make use of the identity limit as theta goes to 0. The sine of theta divided by theta equals to 1. Theta can be any expression that is inside the sine function. It's called the phase, but it does need to go to 0. And it's going to 0 here as x approaches positive infinity. We will need to phase match the sine with what's inside the other position. The sine here is in the numerator, so we'll be phase matching it with something in the denominator. So we will isolate the sine, and we will put it over, by phase matching it, a 1 over x. To compensate, we will put a 1 over x also in the numerator so that they cancel out and it will return back to the original. X times 1 over x, the x's can cancel, leaving a 1. And then sine of 1 over x over 1 over x is perfectly phase matched. And the 1 over x is going to 0, so it has the identity applied to it. And it will go to a 1. The result is 1 times 1, which equals 1. Now to work out the limit as x approaches negative infinity of x times sine of 1 over x. The first thing to do is try plugging a negative infinity in for each of the x's. The result will be negative infinity times 1 over x also goes to 0 as x approaches negative infinity, so it'll be sine of 0. And the result is negative infinity times 0. We have the infinity times 0 indeterminate form here. We will need to rework this. Again, the 0 resulted from a sine of 0, so we can make use of the same identity. We will isolate the sine so that we can phase match by putting it over 1 over x, and then compensate by 1 over x in the numerator. X times 1 over x, we'll be able to cancel the x's out. Which will leave a 1. Sine of 1 over x over 1 over x is phase match, and 1 over x does go to 0 as x approaches negative infinity, so it does have the identity applied to it, and it will go to a 1. The result is 1 times 1, which equals 1. And there's the results of the two different limits.